What up, mathletes? Whoop, whoop. All right, it is 9.6. And learning target is, in my awesome handwriting, I will find the solution region for a system of inequalities. We're talking about inequalities here. Take a moment. You're going to want to pause this, write all this down. This is just greater than or less than. We use either an open dot on a number line or a dashed line on a graph. And this indicates that it does not include the point or the points on the line. If it has the or equal to for greater than or equal to or less than or equal to, it's either a closed dot on a number line or a solid line on a graph, and it does include the point or points on the line. Also, let's not forget, for less than and less than or equal to, it tells us to put our pencil on the line and draw it down and shade that region, because remember, an inequality with two variables indicates a half plane where everything satisfies the inequality. And then greater than or equal to means put your pen or pencil on the line and draw up and shade that region, because that's the half plane that satisfies the inequality. So remember, every inequality on a graph separates that plane in half, where half is the solution region, half is not the solution region. So again, pause this. We're going to move on pretty quick. Get some actual notes on here now. So ready, set. Okay, we're moving on. Awesome. So this is just that paper without that filled out section, because we're going to add some more to it down below. Want to leave yourself a little room right here. I want to talk about what happens when we have, or let's just remind ourselves how to graph y is greater than or equal to 3x plus 1. Okay, let's go ahead and draw just a little grid for ourselves. I'm going to zoom into that. You can see where it's at there. Let's zoom in, and I'll have, label your 5s, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, negative 5. 2, 3, 4, negative 5. Perfect. Okay. And what does this tell us to do? It says, all right, start value is at 1. And then the slope tells us to go up 1, 2, 3 over 1. Or I can go back down 1, 2, 3 over 1. Okay. And then we're going to connect it. I guess I should probably have my handy dandy ruler out. You see in like every video. And it's an or equal to, so this is going to be a solid line. Draw a nice line all the way through. And then greater than tells us to put our pen or pencil on the line, go up, and then we're going to shade that region. And that's the solution region. Let's do one more example. We're going to do y is less than negative 2x plus 1. Again, just draw on it, and I probably should have labeled that x and y. Why not do it the right way, right? 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. And 1, 2, 3, 4, negative 5. Okay, got that all labeled. Awesome. And let's see, start value is the same. It's 1, but the slope tells me to go down 2 over 1. Or I can go up 2 and back 1, right? Now, it's not or equal to, it's just less than, so that's going to be a dashed line. Let's do a dashed line. Again, that tells us that wherever we shade, the solution region includes that shaded area, but not any point on the line itself. And it's less than, so we're going to go down. By the way, this is a good lesson on why we say up or down, not left or right. Because notice, this was greater than, but it's still the left side of the line. This is less than, but it's the left side of the line. Depending on how the slope works out of the line, up or down may be on the same side. So that's why we say up or down for greater than or less than. Awesome. So now we're going to say, all right, what about for the system? So this is how you just graph them individually. We've done this a while back. Now what about for the system? So for the system that contains y is greater than or equal to 3x plus 1, and y is less than negative 2x plus 1. Let's graph the system. So I'm going to pull this up right here. And let's do the first one. So again, start value of 1, slope of 3, 1, 2, 3 over 1. Boom. Down 1, 2, 3, back 1. Awesome. And it was a solid line, right? All the way through. And it's greater than or equal to, so pin on the line, shade up. And you'll notice when I have a defined grid, I just shade in the grid itself. Even though this is technically going forever, like out this way and out this way, right? I'm just shading in the box. Okay, now let's graph the next line. Y is less than negative 2x plus 1, so let's see. Again, starts at 1, but then negative 2, down 2 over 1. And go backwards as well. And this should be a dashed or dotted line. And again, this is less than, so we're going to go down, shade this region. And what does that show us? We want to look for the double shaded region. The double shaded region is the solution region to the system because it's the area where both equations are satisfied. Okay? So that's the double shaded region. This part right here is only shaded for the y is less than negative 2x plus 1. This top part is only shaded for the y is greater than or equal to 3x plus 1. But this area is for both. Okay? And I'm just going to pick a point. 1, 2, 3, negative 4, 1. We're going to write it right here. And I just want you to write solution region. And the definition of a solution region is it's the area where both inequalities are satisfied. So the area, I better move that up, I guess. Sorry, I didn't realize. The solution region is the area where both inequalities are satisfied. And I want to talk about what that means just a little bit. Now, I'm only going to do this once. This is the only time. It's not necessarily a fun exercise that we're going to do, but it's going to help kind of drive the point home of what's going on here. So we're going to plug in test points. I'm going to pick a point from each region and test it in both equations for the system, and we're going to see what happens. So I'm going to start with that point we picked right here, which is the point negative 4, 1. Okay? For negative 4, 1, I'm going to plug it into the top equation. Y is greater than 3x plus 1. Y is greater than or equal to. So 1 is greater than or equal to 3 times negative 4 plus 1, which that's just negative 12. And I get 1 is greater than or equal to negative 11. Guess what? That's true. 1 is definitely greater than negative 11, right? Okay, and then we're going to test the second point, or the second equation. Y is less than negative 2x plus 1. So 1 is less than negative 2 times negative 4 plus 1. Negative 2 times negative 4 is a positive 8. Plus 1 is 9, so 1 is less than 9. Absolutely true. And that's out of the solution region. It should be true for both, and it is. Now I'm going to pick a point up here. So let's pick the point 0, 2. And let's plug it in. 2 is greater than or equal to 3 times 0 plus 1. That goes to 0. 2 is greater than or equal to 1. Definitely true. Let's try to the bottom equation. And we get 2 is less than negative 2 times 0 plus 1, which that's 0. 2 is less than 1. Is that true? Absolutely not. That's not true at all. So just as we suspected, when I pick a point from this top region, it should only work for the top equation. When I pick it from the bottom, That's part of the solution region for the bottom equation. It should only work for that one, but let's test it, okay? So I'm going to pick the point 0, -2, right here. 0, -2. And let's test it out. -2 is greater than or equal to 3 times 0 plus 1. Again, 0. -2 is greater than or equal to 1. That's not true, just as we expected. It shouldn't be, but it should be for the bottom one. Let's see if that works out. -2 is less than -2 times 0 plus 1. Well, that goes to 0. -2 is less than 1. That is absolutely true. It's only true for the bottom equation. Now I want to pick one more point just to kind of nail this whole idea home. If I pick a point out here, this is not in either of the solution regions. This should not work for either one of them, but let's find out. So I pick the point 2, 1. Let's try it. So I'm going to get 1 is greater than or equal to -3, or not -3, +3, sorry, times 2 plus 1, which is just 6 plus 1. 1 is greater than or equal to 7. No way, that's not true. And last but not least, 1 is less than -2 times 2 plus 1, which is just -4, which means 1 is less than -3. Again, not true, just as we suspected, because it's not in the solution region. So that's what it means when we plug in test points, when we have solution regions. That's what it's telling us. When it's in the one where they're both shaded, it works for both. For the top, it only worked for the top equation. The bottom area only worked for the bottom equation. And out here, which wasn't shaded at all, it worked for no one. Okay? One last little example before we go. Well, that's not true. I'm going to do one more thing because it doesn't. Well, we'll just talk about it. So what happens when we're given equations that look like this? 2y minus x is less than or equal to -2. And -2y is less than 4x. Well, when you're given that, you gotta solve for y. Gotta solve for y. So we're gonna do that. I'm gonna add x to both sides. I get 2y is less than, because that crosses out, or equal to x minus 2. And then divide everything by 2. Crosses out, y is less than or equal to, remember, there's a 1 in front of this x, so I can pull that 1/2 out, 1/2 x minus 1, because 2 divided by 2 is 1. Okay, so we have our first equation. Let's graph it. So what are we going to have? Start value of -1, growth value of 1/2, up 1 over 2, or down 1 back 2, okay? And it's or equal to, so we're going to use a solid line. And then it says less than or equal to, so pin on the line, draw it down. Again, I just shade in that box area. Let's do the next one. This one, all I got to do is divide both sides by -2. However, when I divide by negative, what happens to the sign? It flips, so I should have y is greater than -2x. Which that has no start value, so a start value of 0. -2 says down 2 over 1, or up 2 back 1. And it's just greater than, so that means dashed line. Greater than says pin on the line, draw up. We're going to shade this area. And then where's the area where they're both shaded? Right there. Both shaded there. That is the solution region. Awesome. Make sure to take a minute. Let me zoom out so you can have a little picture of everything. Good notes today, right? Pause this if you need to. We got to move on to the back real quick. I want to show you guys something. Number one, look back here. Everybody on the very back page of this packet, right? Choose 3. You only need to solve 3 of these. And then, last but not least, I do want to talk right here. most of these questions are fine. The one that I had some concern on was right here because it just looks a little, some of these feel like they could go multiple places, but the solution of a system of linear equalities are the ordered pairs, right, the xy points, ordered pairs, and I realized I should have an E right there. So we just use that are solutions to all inequalities in that system, because there could be more than two, there could be 3, 4, 5. On a graph, the solutions to a system of inequalities is the, well, we had all, intersection of the half planes, or where the shaded regions overlap. The double shaded area, right? Okay, that's it for notes today. With that said, peace out. Have a great day, y'all.